Okie dokie, so for this video, I'm going to talk to you about material properties. Now, this might be something you've never heard of before, but it also might be something that you recognize from either year 7 or year 8. So if you don't know what this term means, material properties, please don't panic. It's not the end of the world, because hopefully this lesson will give you a really good understanding as to what it is. So we're going to do a quick starter just to get our mind flowing and get ourselves into the right mindset for this activity. So first of all, I want you to look at the products below. All of these products have been made out of the same type of polymer, so either a thermosetting or thermoforming, and they have been specifically chosen. So what I'd like you to do, just on your own, I want you to think, why have these polymers, or why has this polymer been chosen for these products? And I'm going to give you a product in particular. I'm going to give you the chocolate tray. So why do you think that this polymer has been chosen to make this chocolate tray? If you're sat there thinking, well, hold on a minute, I don't know what the polymer is, you haven't given me a name, that's fine. You don't need to know a name. All you need to do is look at this product and think, right, what does this polymer need to do in order for this chocolate tray to actually do its job, in order for it to actually work? So take a few minutes of just, reflection. You can write your ideas down on some scrap paper, or you can use a whiteboard. It's entirely up to you. But pause the video and have a little think. So these are the ideas that I came up with. I came up with it's food safe. So it's suitable to actually hold the chocolates. It's actually food safe. It can hold chocolate and not contaminate it. I've decided that it needs to be moldable because it's got those little dips in it, and I'm guessing this has been made in one solid piece and not with like little bits of plastic all glued together, so it needs to be moldable, and I'm going to guess they want that to be done quite easily to, not to worry about manufacturing time, so that's why I put that. I've also put because it's black in colour, so they probably wanted it to be black because it is, so that's why I put that. And I made a suggestion as to it could be recycled, because a lot of our food packaging, as a design industry, we're trying really hard to make our food packaging more recyclable because of the amount of waste we produce. So I guess that as well. So these are the reasons why I think that polymer was chosen to make that product. But whenever we choose a material to make something, we always consider what it looks like. We consider how easy it is to work with, whether it's readily available, but more importantly, we think to ourselves, will that material actually help the products that I want to make? Will it help it to actually function? Will it actually help it to do its job? And there's something that we really need to think about or identify that's going to help us make that decision. And that is material properties. So every material has a material property to them, more than one in fact. But let's break it down. What do we think this word actually means? Material property. So again, you can pause the video here. You might want to go Google it real quick and come back. Choice is entirely up to you. You might want to write down your ideas. You might want to be on a scrap bit of paper or your whiteboard. Entirely up to you. But what do you think the following term actually means? Let's break it down. Material. What is a material? A material is a natural or synthetic product used to manufacture other products. So it means we can either plant and grow something to actually make something, or we can make a material in order to make a product. So let me give you an example, because that's really confusing. A natural material would be timber or wood. We grow trees, we chop them down, we convert them into usable planks or bars to then build houses or tables or chairs. So that's a natural material. A synthetic material is something that we've had to make it ourselves. We can't just plant a polymer tree and hope that some sheets of plastic appear. So instead we have to dig into the Earth's crust, get our hands on some crude oil, and then convert that crude oil into polymers, teeny tiny polymer pellets. We then turn that polymer pellet into a sheet of polymer. So that's a synthetic material. It's a material that it's not been made out of natural resources, so like a tree has. It's been made out of something that's finite, something that's going to run out, and we've had to convert it ourselves in a factory using a lot of labour. So that's why it's called synthetic. It's not natural, basically. So that's what material is. So what is a property? Now I googled this and I really like this definition. So the definition of property is a quality or trait belonging and especially peculiar to an individual or a thing. So it just means something that something has. So what does that mean when we bring these two terms together? A material property means the qualities of a material. So I can break this down even further, and I'll do that in a moment. But every material, no matter what it is, it has several properties. And these properties will help define the material or help us to identify what the material can actually be used for. And it will help us to decide whether that material is suitable for the product we want to make. Now, similar to polymers, there are two categories to materials. We have physical properties and we have working properties. And we're going to focus on physical properties first of all. So when I say physical properties, what I mean is a term used to describe the look and structure of a material. So you can think of them like DNA. So I'm going to give you an example. If a physical property is, like a material's DNA, what that means is it's something that you could probably hide about this material, but you can't get rid of it. It will always be there. So a lovely example of this is hair. I am brunette, my hair is brown. Now I can change this by either shaving all my hair off, or I can dye my hair a new color like blonde, red, or even blue if I really, really wanted to. But no matter what, my hair will grow back. And it will grow back to its natural color, which is brown. It's part of my DNA. I can hide it, but I can't get rid of it. Materials have the same thing. It won't be hair, but they'll have their own physical properties that we can enhance so we can improve them, but we can't remove them. They're not going anywhere. So we're going to focus on these physical properties first, and we'll pop back to working properties later on. So physical properties. Let's get a bit of a brain break. Let's get you guys actually doing something. So below, these are 5 different types of physical properties that a material could have. I'm not saying they all have them, they could have them. So what I'd like you to do, either on paper using a pen or pencil, or again on computer software such as Word or PowerPoint, I'd like you to write the title, Physical Properties, and then underneath that title, it could be a bullet point list or a mind map, I really don't mind, I would like you to write the material properties listed below. So I want you to write resistance to moisture, electrical conductivity, absorbency, thermal conductivity, and then my favorite one, fusibility. So write those down on your sheets or on your Word document, pause the video here, and come back when you're ready. Task 2. Again, bit of a brain break. Let's get you guys doing something. Let's get you guys moving. Now that you've written the title and all the names, I've got some pictures below that go with them to suggest what these words mean. So what I'd like you to do, using the pictures to help you, I would like you to suggest the definition for each of these physical properties. So one's been done for you. So if we look on the left, it says resistance to moisture, and I've got a little umbrella with some raindrops on it. The definition is ability to prevent liquid absorbing into the surface. I chose that because that's what an umbrella does. So you've got one definition. I'd like you to write the other definitions for the other 4 properties. So that's electrical conductivity, absorbency, thermal conductivity, and fusibility. The answers will be shown to you in a moment, but if you'd rather Google them, do feel free. Choice is entirely up to you. But I'm going to give you a good 10 minutes to actually have a think about this. Try and think about it first before you hunt out the answers. Okie dokie. So resistance to moisture, that one's already done for you. Electrical conductivity. How easy a material conducts electrical energy. So you've got the plug socket there. Can electricity actually flow through it or not? Does it conduct it, so let it flow, or does it insulate it? Does it stop it? Absorbency. How easy a material soaks up and retains liquid, heat, or light. And that's the important thing about this material property. It's not just related to water. So whenever I think of absorbency, I immediately think of a sponge, because that's what it does. It soaks up water. But we forget it actually then holds that water. It retains it. It retains liquid, but it can also retain heat or light. So that's absorbency. Thermal conductivity, how heat energy can pass through a material. So a lovely example of this is lots of metals. Lots of metals can conduct heat or thermal energy really quite easily. For example, I'm sat next to my stove, which is ceramic, but all of my pots and pans are made out of stainless steel or raw iron, and that's because they conduct heat really, really easily, which means that I'm not waiting 5 hours for my pan to heat up before I actually start cooking my dinner. And then finally, my favourite one, fusibility. So this is actually how easy a material turns into a liquid state from a solid. I chose the ice cube there as a nice little visual, but if you've ever done the Moodlight project with us, you would have used a metal material called solder to create your circuit boards. And solder is a wonderful example of a material that has the material property of fusibility, because solder is given to you in the form of a wire shape. It's very, very malleable. You can bend it and move it quite easily. But also, when you apply heat to it, it turns from a solid into a liquid. So, now that you've done that, you've checked your work, we're going to go back to our material properties. We've discussed physical properties. Now we're going to go on to working properties. So, working properties, what does this actually mean? I'll tell you. It means the properties a material displays when it is being worked with. So when we're cutting into it or when we're abrading it to a certain shape or size. So next task. Look at the images below. These are examples of working properties. Really similar to the tasks you've just done. I would like you to write down the new title of mechanical properties, still on the same work that you've started. So you don't need to grab a new sheet if you don't need to. Once you've written down that title, I then want you to write down each name of the material properties, the working properties that you see below. So we've got strength, malleability, toughness, hardness, and ductility. So write down each title. Feel free to pause the video and then pop back for your next task. Next task, task 4. Very similar to what you've just done. Now that you've written the new title of working properties and you've written each name of those properties from below, I'd now like you to look at the pictures and add what you think the definitions are. So one has been done for you. It says strength, and then the definition is ability to withstand a constant force without breaking. So that's strength. So that you need to write down that definition underneath the word strength. But what does malleability, toughness, hardness, and ductility, what do you think they mean just by looking at those images? Again, the answers will all be revealed, but pause the video, take a couple minutes to have a think, write down your definitions before you come back for the answers. So there they all are. I didn't bang them out this time. Malleability. Material's ability to be deformed or shaped by impact, rolling, or pressing. So I always think of Play-Doh, because Play-Doh you can do all those things with to create new shapes. Toughness is one of my absolute favorites. Ability to withstand impact or shock. So what that means is you can really hit the material, and instead of just shattering into a million pieces or just starting to crack, it will absorb that shock, and that's that. It won't wear, it won't tear. Obviously, it will break over time, but not straight away, and that's toughness. Hardness. I always think of cats for this because it's the ability to withstand cutting, scratching, and abrasion. And I don't know about you, but my cat is constantly scratching my carpet at home. So ability to withstand cutting, scratching, and abrasion. And then finally, ductility, material's ability to be drawn into a long length. So I have an elastic band there because when you pull an elastic band at either end, you can draw it out into a long length or a thin shape, and it won't break, it won't damage, it won't lose any of its original properties. It just gets a little bit smaller, a little bit thinner, but it'll still be nice and strong. So that's ductility. Whew, so that was a lot of information to take in. So now I'd like you to do a knowledge consolidation task. So that's taking all the information that we've gone over and using them to create something. First thing I'd like you to do is answer the question, number 1. We must always consider the properties of a material when choosing one to make a product. Why do you think that is? So I'm not after a correct answer here. I just want your opinion using full sentences. We must always consider the properties of a material when choosing one to make a product. Why do you think that is? So that's task 1. Task 2, I would like you to read through the material properties below and create a pictogram that will help suggest what the property means. If you're not sure, look back on the ones that I've just shown you previously in the lesson, or Google, clipart, whatever you fancy. Some of them we've heard of before, but one of them might be new. So what pictogram would you put with those material properties? And again, this can be completed on the paper that you've already been using, a Word document, PowerPoint, whatever you want. Whatever you create, you must bring the physical copy to your next lesson with your teacher.